Every audio environment has some noise present other than your desired signal. In your house, it will be the sound of your air conditioner, your refrigerator, or your neighbor's dog barking. In a park, it'll be the birds, the leaves rustling, and cars going by. In audio gear, it's the noise introduced by the electrical components in the device. This ambient noise is called the noise floor. Whether it's your conversation at a restaurant or an acoustic guitar and a microphone, you want your signal to be as far above the noise floor as possible. And the higher above the noise floor you get, the better clarity you get. This relationship between the noise floor and your signal is called the signal-to-noise ratio. On the opposite end of the spectrum, every system has a maximum sound level it can reproduce. For an electrical circuit, it's the point where one of the circuit's components reaches its voltage limit and fails. For a dynamic microphone or speaker, it's the maximum travel of the coil. Hitting one of these maximums is called overdriving, in reference to one or more of the system components being pushed past its tolerances, and results in clipping, where the peaks of your waveform get squared off or clipped, resulting in a distorted sound. A good example of this that we're all hopefully familiar with is the human voice. When you talk, it sounds normal. Talk louder and you start yelling, and your voice gets distorted and your words become less intelligible. In all of these cases, your goal should be to get your signal as far above the noise floor as possible without overdriving the system. This process of adding enough gain to get a clear signal, but not enough to clip, is called gain structure, and is considered at any time you are moving a signal from one audio environment to another. So how do you set up proper gain structure? First, you want to lower the noise floor, and then boost your signal to get it close to, but still under the clip threshold of the next device. For an acoustic environment, this means getting your room as quiet as possible, lowering the noise floor, and placing your mic close to your source. In the electrical domain, the noise floor of each device is defined by the device's circuit design and components. So to lower the noise floor, you use higher quality components. If you need to raise the signal level, you can add volume with an amplifier controlled by a gain knob. In a sound system, different devices run at very different levels, commonly referred to as mic level, line level, and speaker level. The gain structure needs to be set up for every stage of the system, including stages that happen inside of individual devices. Each device in the system also has a noise floor that is relative to the maximum output of the device. So a microphone will have a much lower noise floor than a mixer, and these noise floors add up as the signal works its way through the system. You could run everything through the mixer at mic level, and then boost it to line level before you go to your amplifiers. But in doing this, you will boost the noise floor of the mixer as well as your signal. The better way to do this is to boost your microphone up to line level as soon as it enters the mixer, before the mixer's noise floor gets added to your signal. The easiest way to do this is to use the meters built into each device. Adjust your signal to be at the sweet spot, usually the transition from green to yellow, at each meter it goes through, and you'll have a strong, clean signal from end to end. Another thing to remember is that anytime you change sources or microphones or any part of the system, you'll have to adjust your gain structure to compensate. Hopefully you enjoyed this video. Keep an eye out for more videos on basic audio principles, and don't forget to like and subscribe.
She asked how was New Year's Eve, and I turned and